Hello! In the shed for a while I've wanted a DC monitor, volts, amps, watts, which also has Tuya so that I can see on my phone what the state of charge of the battery is in the shed. Now for a while you've been able to get AC monitoring units like this unit here. Unfortunately, can you see that? Just about. The screen's not very bright, but this one AC comes in, obviously AC comes out. You get your measurements. There we are, 230 volts. And I can see that on my Tuya Smart app. There it is. It's the smart energy meter. If I go into that, it's not very large, but there's the voltage, 230.15 volts. There's no current, no power at the moment. There's also frequency, 49.99 hertz. This, in case you're interested, is an Atorch product. I think you can see Atorch at the top there, yeah. And it's the S1 AC power meter. But what I couldn't find was a DC power meter until now. So this is another Atorch product, and it's a DC power meter, electric energy meter, it says there. It has a whopping great 100 amp current shunt on it. Now you can get it in different shunt sizes. You can get a 30 amp shunt, I think it is, which is just a resistor on the board. But the 100 amp up to 400 amp are these big off the board current shunts sitting on two little pillars there. So this is the 100 amp, goes up to I think 420 volts or something ridiculous. And shows watts and all sorts of other things on the display. So this is the DT20. Shows up on here actually as the DT20 HBW. And it's supplied with copper lugs in there and a temperature probe, which is actually on a little flexible PCB there, and also USB A to C cable. So I'm going to power it on. There's a little, well, there are two actually, USB Type-C sockets on here. One of them is used in conjunction with an external relay, which you can buy for this thing. And one of them is called HID, Human Interface Device, I think that is. But I think it's that top one there. Let's try it. There's a power bank on the other end of this cable. Yeah, and so you get volts, amps, watts. You've got overvolt trigger, low voltage trigger, and overpower trigger. Another display is this one where you can set the high voltage for the trigger, the low voltage for the trigger. You've got capacity counters. This is milliamp hours. You've got an energy counter. That's in watt hours. And at the bottom you've got the CPU temperature. That's the temperature inside this box. You've got the external temperature, which would show up if you had this thing plugged in, and you've got a timer which doesn't run if the current is below a certain threshold. I think it's 30 milliamps. Okay, let's get in nice and close and look at the screens available. So you've got this one with the overvoltage and low voltage trigger. You've got this one with a battery state of charge indicator, but it's not a state of charge indicator. What this is simply the percentage that the input voltage is at between your low voltage setting and your high voltage setting. So as these are currently set up, if I had 7 volts on the input voltage connector is this thing, which nothing is connected to yet. Then this would show 50%. On here you've got ohms, kilowatt hours, strangely, and amp hours as well. The next screen is a graphing screen. So it's graphing volts down here, which is 0, and amps, which is also 0. I think it put amps in the middle there because you can have negative amps and you can have positive amps. And the next screen is just the basic numbers in very large. So yeah, 5 screens. If you press and hold M, you go into the setup, and there's all sorts of things you can set up, including calibrating the voltage and current. You can also set the high voltage prompt and the low voltage prompt. What else is in here? set the 0 no load current, set up the Wi-Fi, which is already set up, zero all the data. Mini measure amp, I think, is the amount of current below which it just says, oh, it's 0, and it stops the counters counting. If I go into that, oh, that's set to 50 milliamps. I think it was set to 30 milliamps and I changed it to 50 milliamps. No, long press changes the field you're editing. Short press comes out, but I think long press comes out of the settings. Okay, let's unplug that. And I'm just going to take this module out of its case briefly because it's relatively easy to do. So just push on these little pegs. If I can see them. Maybe I'll do it at the other end. It was easy to do because I've already done it. Right, there it is. Okay. And after lots of messing about, yeah, that's come out. Sorry about the lighting, incidentally. There's a big battery in front of here. I'll show that in a minute because that's what I'm going to use in conjunction with this. Okay, so that's a little overlay which sits in there. So LCD screen, 3 buttons, the big shunt, which is, as I say, mounted on these pillars, and the shunt actually interferes with the positive connection of the 4-wire connector. You put positive and negative connectors in here and take them straight to the battery to get accurate voltage measurements. Now you will get less accurate voltage measurements if you don't use these. You can just put current through here, and I'll show that with the external USB powering this device. There are slotted holes down on the PCB, and I thought if I shifted this over, I could just clear that huge bolt from obscuring the screw for the positive connection. But unfortunately, the screws that are holding these 2 pillars on are underneath some self-adhesive foam, which is being used to hold the display on. So to get to those screws, you'd have to sort of lever the display off, and I'm not sure I really want to do that. But anyway, let's get some connections onto here. Now I made up some cables, a couple of thick M8 to banana socket short cables, and I've got a positive connection with a little tab on the end there, which can go into there with a banana plug. So let's get the current connections on at least. And I've done them in black because this sits on the negative side of your battery connection. In fact, one of these connections, let's see if I can see which one it is. Yeah, this one has to be connected to battery negative. See if we can see that. Yeah, B minus, V minus. And this one goes to either your load or to your charger if you're charging the battery. And this will show current bidirectionally. So I'm just going to take these bolts out. They're massive bolts, and you know, there's a temptation to be very hard on these, but then you've got this tiny little Wi-Fi module and very exposed things like the USB Type-C sockets. So you've just got to be a little bit gentle with all of this. Yes, dropping that huge M8 bolt in there is probably not a brilliant idea. Right, I've connected these 2 banana sockets because everything I've got on the bench is being done with bananas. To these 2 big M8 bolts, I've put the bolts the other way around so that the threaded bit means that I've just about got access to that positive connection. It's not ideal though. Would have been better if that had been pushed across. Okay, let's just put the positive terminal into here and screw that down. Right, so I've got the big LiFePO4 105 amp batteries here. I've got a negative connection here with a little banana linker. So let's put these negative connections into my shunt, and now I've got to get this powered up. Now interestingly, it says you absolutely must power it from 5-volt USB. So let's do that if I can find that USB socket, and I'll now arrange for a load to be on the battery. So I have off to the side this contraption. into which I can put a little light bulb, 24 volt light bulb. So let's put that on. Okay, that's now illuminated. It's only 12 volt the battery, and this is 24 volt bulb, so it's quite dim. I'll put that off to the side, and you can see here that we got 0.68 amps, and you can also see that there's a little arrow pointing to the right. Now you have to imagine that the battery is on the left, because the battery negative connection is this left hand one, so that does go off to battery negative. So what this means is energy is coming, or current is coming out of the battery and going off to the other side, which has that little light bulb. Now we can't see voltage at the moment, because in order to see that, I have to connect this positive cable, which I can do, to positive of the battery, and I'll just show that. So on the battery, I've got various positives. I've got a big common block here. That's the main feed from the battery, this top one. This one goes off to the right. That goes off to the positive of the bulb. This one goes off to another energy monitor, which is that BL105 coulometer device, which is running, but I probably won't show it. But I've got this other positive, which I can connect into here. And that means that this device can now see the voltage of the battery, so it's 13.38 volts, and we've still got this 0.66 amps of current flowing out, hence the arrow, and 8.8 watts of power. And if I go to the other screen, which has milliamp hours and milliwatt hours, actually no, they're watt hours, you can see that they are counting. Can you see that they are counting? Yes, that's just gone up to 9537. Okay, let's bring in the Tuya app. So this is the one, DH20 HBW, DT20 HBW. So I'll go to that, and we can see that on here we've got the voltage 13.37. Now it's a little bit laggy unless you turn on this real-time switch button. Yeah. Which will now make these figures come through immediately or within 2 or 3 seconds. So I suppose that just speeds up the rate of transfer. So we can see voltage, current and power in watts, and even resistance, and total capacity, which should match this number, 9549. Yeah, 9.548. As I say, it's a little bit behind. Now, I have discovered that this will actually stay powered on even if I take the USB 5 volts out. But it does say on the listing for this thing, and I'll put a link to it in the description, absolutely you must have this powered externally. Now, this can take up to 400 or measure up to 420 volts. So you've got 420 volts coming in here. How on earth do they regulate that down to 5 volts or 3.3 volts? I mean, I know it's doable, but it's a massive reduction in voltage. This unit is never going to see 420 volts on its input, nowhere near, but it will see probably 40 volts because the solar panels outside the shed can go up to that. It does appear to work like this, but I have seen it just occasionally randomly reboot. The screen goes off and it just reboots. So possibly that's what they're getting at in the listing for this device. You can power it from the positive measure input, but it's unstable, and so you're better off providing a separate 5 volt power supply to this unit. Right, so what I want to do now is charge the battery. So I'm going to use this power supply, which I'll just place there with wires strewn across the table here. These two positions I will connect in place of this light bulb. I'll simply remove the light bulb from these two connection points and connect that power supply in order to charge the battery, and then we should see the right pointing arrow start pointing left. If I start by actually removing the bulb, we get 0 current, of course. It can still see the voltage of the battery through this red wire, but now I want to put some charge into the battery, and we should see the current flowing in the other direction. Right, that's connected up. This power supply is running at 2 amps, and you can see that 2 amps here on the display. And now we can see that the arrow is pointing left, and so this is a charge or a current of 2 amps going into the battery. So what does the Tuya app make of this? Well, yes, it can see the 2.02 amps, the voltage, and that's a BBC News breaking news thing. And we can see the power. But what's interesting is that there's nothing on here which shows the direction of current. And as you saw, when the bulb was connected to the battery, we saw a positive current. And when the charger is connected to the battery, you also see a positive current. And you can't tell which direction it's going in. So I thought, well, that's not a problem. We can simply look at the milliamp hour count, and you can see here that it's counting 9640, 9643. So that's counting up. But curiously, when I had the bulb on this unit, which I now have, so we have the 0.67 amps, but it is flowing in the other direction. But on here, the amp hour count, 9654, is still counting up, 9655. So unfortunately, oh, that's my phone going dim. What they've done here is they've implemented this bidirectional current measurement. They've got a little arrow on the display of this unit, but they haven't relayed the direction of current flow to the app, so you don't know whether it's charging or discharging. And of course, on the battery in the shed, it does both, even at the same time. And you can't even tell from the counting up amp hours and watt hours. Here it's kilowatt hours for some strange reason. You can't tell whether it's current going into the battery or current coming out. So they very effectively stopped you knowing which direction it's flowing in. Which makes these counters, the capacity in milliamp hours and the energy in watt hours, a bit useless, because irrespective of which way current is flowing into the battery, these count up. So of course, immediately you change direction on the current flow, this is wrong, because you've changed direction, but the counter is still always going upwards. So certainly I think on the next firmware upgrade, Atorch need to change this so that it counts up one way and counts down the other way. And that of course would then enable the app, which they should also change quite frankly, to show the direction of current flow. Now I've switched to another screen. This is the one that shows a state of charge indicator. But it's not state of charge. It's simply, and you can set these, the upper voltage, which I've set to 14 volts, because that's what I'm saying is the full charge on the battery. The lower voltage I've had to set to 0. I did have it set to like 13 so that I could see this moving between those two voltages. But then when I disconnect this red wire, this thing starts screeching, beeping the alarm and saying below the bottom voltage, which I can show you actually if you want. This is quite easy to edit. You just press M and then you move through these fields. So I can very quickly set this one, down is up for some reason, and to 13 volts. So now you can see that we're between 13 and 14 volts. In fact, we're 0.38 volts between them, which is why we're seeing 37%. But now if now I've got my USB power on there, if I disconnect this positive so that it's measuring 0 volts, it immediately says, and that's my phone sending me alerts, it immediately says, oh, there's a problem, you're below 13 volts. And it won't shut up. It just keeps beeping. You can probably hear the beeper on the back of the board there. So you have to long press M and go into here and go down to the low voltage prompt and then alter this. And there is a way of doing it. It's slightly odd. You press and hold to move between fields. And then again, that's negative, I think. You have to set this down to 0 just to shut it up. Or alternatively, I could simply plug this back in. That should then, I think you press that to come out and press and hold that to come out. Yeah, that should shut it up because it's now, the state of charge indicator now shows where you are between 10 volts and 14 volts. And since we're at 13.36, it thinks that we're at 84%. So not only are these top of the voltage indicator setting and bottom of the voltage indicator setting, they're also the triggers for the alarm, which strikes me as rather odd, because I would have thought that you would set the top of voltage into the full voltage indicator to indicate when the battery is full, and the 0 voltage indicator to indicate when it's empty, which won't be 0 volts. But have over voltage triggers set slightly above and below those numbers. But no, these are dual function parameters. They work as both the triggers and the top and bottom of the state of charge indicator voltage parameters. And as I say, this is not a state of charge indicator, because lithium iron phosphate has this very flat center part. And this is simply a linear indicator saying where you are between your lower setting and your upper setting. So it is not battery state of charge or anything like. The graph now, what are we seeing here? If I switch off the power supply, no, it's a light bulb at the moment. I'll take the light bulb out and we should see the current, which was negative actually, because it's current coming out of the battery, now goes to 0. So the current is now 0. And if I put on the power supply, we now have a positive current. For some reason on this graph page, it doesn't actually show you the current values of voltage and current. But you can see we've got a positive current. That was the 0 current. And this was the negative current going to the bulb. This is the 0 current when neither the bulb nor charger were connected. Oh, the voltage is shooting up actually. That's because I'm charging the battery. This is a positive current from the charger, and you can see that the voltage of the battery pack is creeping up. It's got these max values, and these are volts per division and amps per division and time per division. But nowhere does it show you on this page the actual voltage and the actual current, which is strange. I mean, they are on the next page, of course. And that's it, I think. That's all it does. If you press and hold either the pause or neg button, for some reason that little indicator turns orange. And if you press and hold it again, it turns green. And I've absolutely no idea why, because all it indicates is which page you're on. Page 1, page 2, page 3 with the not state of charge indicator, page 4 the graphs, and page 5 the large font display. So yeah, I can't quite understand why it has to go orange. So that's it. 5 pages of displayed data, and of course you've got the Tuya app, so that you can see all of these parameters remotely. You can switch on the rapid, oh, there's my low voltage alarm, which I haven't cancelled yet. Probably got a couple of those. Yeah, so you can see the rapid data, but the one thing you can't see is direction of current travel. So I won't know whether the battery in the shed is being charged or discharged. I'll just have to make an intelligent guess. And these amp hour and watt hour counters don't help. So that's it. That's the Atorch. The Atorch DC20 HBW DC power meter with Wi-Fi and integration with the Tuya app. The first that I found DC power meter that has the Tuya functionality. Well, actually not quite the first. Just prior to buying the DT20, I did buy this, which is really a USB analyzer. It's got Type-C inputs, Type-C out, but it's also got Type-A, of course. It's also got this DC barrel jack in and DC barrel jack out, and it goes up to 50 volts, but it only goes up to 6.5 amps. So it's not really very useful in the shed, because my currents go up to about 10 amps. This does have Wi-Fi, but it's as an external sort of dongle thing, which you have to connect to the HID port. And it has a few issues. If you're interested in this, I can make a video about it, but I don't really want to put too much emphasis on it in this video. And just in case you're interested, that device is called the C13P plus UD24P, and it's actually there. Also, I bought an air conditioner recently, and that had Tuya integration. And the other thing which shows up on my phone is the electronic DC load, the DL24, which also has Tuya, which you can monitor remotely. But that's it for this video, so cheerio.